Alright, today we are going to talk about those chemical formulas we've been working on and putting them into an actual equation. So we're going to start today with taking some notes. So in your journal, I need you to get your notebook ready on next clean page, and we are going to take our notes today. First, we are going to draw nice and big at the top of our page a big R, a big A, and a big P. And this is going to stand for reactants, arrow, products. So we're going to wrap a chemical equation today. So reactants, arrow, products. And you're actually going to, if you wouldn't mind, draw an arrow in here. And we're going to put underneath it a chemical equation. So we are going to wrap a chemical equation today. So we are going to use those formulas we learned how to count last lesson to put these together in an actual equation. So when we're wrapping a chemical equation, the first thing you need to know is our reactants. So write reactants. Yield our products. And if you think about a reaction, it's something that starts something else. So in this case, our reactants are going to be the starting chemicals. Our products over here are going to be our newly formed chemicals. And then in the middle here, our yield. Yield is another word that is going to mean shows a chemical reaction or makes a chemical reaction or equals. So our reactants equal our products. So under yield, we are going to write, so we're going to draw our little arrow again, and we're going to write shows or equals. So in science, we want everything to balance out. So our reactants have to balance out with our products. And if they do not balance, then we have what we call an anomaly or something that's not correct, because there is a law that says matter cannot be created or destroyed, it's only changed. So this right here, our wrapping of our wrapping of our chemical equations is showing that our reactants are balanced out with our products. So under here, I would like for you to write this chemical equation. C6H12O6. Oh, let me scoot that up a little. Hold on. And then we're going to put a plus sign, plus 6O2. And we have learned this last week that all of these are subscripts. So everybody write subscripts. And we have learned that this number right here is a coefficient. So everybody write coefficient. Now, our yield arrow, so write your arrow in right there. and we're going to finish our equation. And it's going to be 6 CO2 plus 6 H2O. Now, same thing over here. We have some coefficients and we have some subscripts. I would like for you to please circle H2O and label that chemical formula. It's not the only one, because actually CO2 is one, C6H12O6 is another chemical formula. We're just going to label this one just so we know that that's a chemical formula. And then I would like for you to bubble or box this in. And this whole thing, so I'm going to label this whole thing, is now a chemical equation. And the last thing I want to add to this one is right here up above the arrow, write yields, because we always need to remember our arrow means yields. Alright, so let's go back and look at this chemical equation. So over here we have two chemical formulas. We have sugar, C6H12O6, plus oxygen, 6O2, and it yields or makes these two formulas, 6CO2 and 6H2O. Now, this looks like a lot of a mess going on here. But when we look at this, I'm going to pull this piece of paper out to the side for a second. And I want to look at like we did last week. So if we have C, H, and O in our chemical formula right here, we have 6 C's, we have 12 H's, and we have 6 O's. Then, if we look at this formula over here, so we're going to break it in half, we have O. And it's O2. So you have to remember, 6 times 2 is going to give you 12. Now this is a chemical equation, and it's telling us to add these together. So when you add them all together, you're going to have C6H12, and then you're going to add your O's because they're the same. So you're going to have O18. So that's one side of the equation. And we need to check if it matches the other side of the equation. So we're going to break it in half. So looking here, we have a carbon and an oxygen. So this 6 goes with the C and with the O. So that tells us we have 6 carbons, and then we have 6 times 2, which means we have 12 O's. And then I'm going to move it over here, and I'm going to cover this one up, and I'm going to look at this. Over here I have H, O. Now this 6 multiplies by the 2 H's, which gives you 12. And then 6 times 1 gives you 6. And remember, we're adding them together. So we're going to have C equals 6. H is 12. And then O, add those two together because they're the similar, 18. So when you're looking at these chemical equations, you're going to notice C is 6, H is 12, O is 18. These are the same even though they've been rearranged. So we just took, I'm going to put this up here for a second. We just took our chemical equation, which is totally different on each side, and checked to see how it looks. And we have realized that these numbers are equal on both sides. That means our equation is balanced. And we want our equation to be balanced because the law of conservation of matter says matter cannot be created or destroyed. It's only changed. So we didn't make anything brand new. We just changed it into a new chemical formula. So we took the old and we rearranged it into the new chemical formulas. So I want to add 2 more things down here. I want you to add over here the word balanced. And atoms are equal on both sides of formula or equation. Sides of equation. So balanced on both sides of the equation. And let's put a box around that. Okay? And we're going to scooch over to this side, and I want you to write the word unbalanced. And this is a bad thing to be unbalanced. That means something went wrong. So you're going to put atoms are not, let's write not real big, equal in the equation. And if they're unbalanced, you got to figure out how to make them balanced. What went wrong when the equation was written? And so that's something you're actually going to do either in advanced science or when you get to chemistry in high school. Our on-level classes, we're going to leave it right here. It's either balanced or unbalanced. You're just going to stop with that. You're going to be able to tell the difference between the two. For our advanced science classes, we are going to work on how to figure out if they're balanced or unbalanced. All right. The next thing I want you to do is we are going to do a lab, and it is in your Google Classroom. You're going to open up the lab. It's going to look just like the classes does. It's just going to be digital. So you're going to follow the instructions on that lab and get that done. And then you're going to do this sheet, which is uploaded as well. You're just going to figure out how it is balanced or not, or if it is balanced or not. And the way I would like for you to set this up is where we have an arrow, we're going to make like a T-chart. And on this side we have H and O. And on this side we have H and O. So we're going to set it up like this. And then we're just going to count our atoms. So in this case we have 2 H's and we have 2 O's. Then on this side we have 2 H's, but notice we only have 1 O. So the H's match, the O's do not. So that is going to be unbalanced. And you're going to do the T-chart for the rest of these all the way down. And that'll be your lesson for today. So you should have written the notes with me, completed the digital lab that the class is going to be completing today in lab groups, and lastly, balanced versus unbalanced. All right, so good luck. I hope you have a good day. Please email or message me with questions. All right, bye guys.